Today's webinar topic is assessment of reduction in capacity of reservoir due to sedimentation. You all know that what is reservoir, what is sediment, and what is reservoir capacity. These three terms are very much important terms. You are all civil engineers, I suppose. So I think I'll start with the basics and then we'll go one by one to the methodology. I am Dr. Uday Roman. So let's begin with the seminar. I'm just introducing yourself because whenever one river is flowing, you know a river, where from river comes? River comes from the catchment. Whenever rainfall is there, there are depressions. There are depressions, and from through that depressions, the river, the rainfall water flows, and it flows through the gullies, it flows to the rivulets, it flows to the channels, and finally comes to the river. So it forms a shape of river, and it goes to the reservoir, we say. So how that reservoir is created, you can see here. This is the cloud. From the clouds, rains are there, and it's a total catchment area, or you can say it's a watershed area where valleys and rivulets are there. So all rivulets are contributing their drop of water to a river. So the river is generated, and this river is now flowing. Now what happens when this flow of water is obstructed? Suppose I am constructing a dam here. Okay, when we are constructing a dam, this flow of water is now obstructed. So what will happen? The velocity of that flowing river is reduced. Whenever velocity of flowing river is reduced, it means zero velocity is there. It means ponding will be there. There will be no flow because velocity is not there. So there is no flow. That's why there will be a ponding there. You must be seeing the arrow. There will be a ponding, or we can say it's a storage. So storage behind a dam is called the reservoir. Okay, it's a pond, or it's a water body created behind the dam, behind the obstruction on the river. It is called the reservoir. Okay, now this reservoir may depend upon the shape of the valley. And it may depend upon the shape of the valley. The shape of the valley may be shallow also. It may be a gorge portion also, deep portion also. So you can say it's an elongated shape reservoir is developed. That river flow is obstructed, and the backwater of that elongated shape reservoir is going far away. But here you can say in the fan shaped reservoir, if you create a dam, only few storage can be seen as a fan shaped storage. Means it's not a elongated shape, it's a fan shaped storage. Means it is more visible in the plan, you can see. So there may be a gourd-shaped reservoir also. There may be a belly-shaped reservoir also. There may be U-shaped reservoir, V-shaped reservoir. Number of types of reservoirs are there. But as our lecture is concerned, we are mainly concentrating ourselves from the to the two reservoir shapes. One is elongated shaped reservoir and fan-shaped reservoir. You can better understand from the figures also. Now, the volume of water which is created behind the dam, which is deposited behind the dam, creating a reservoir, it is called the capacity, because that volume, some capacity is developed. Capacity of glass, capacity of bottle, capacity of container, capacity of bucket. We say that it is in liters, but because it is a huge storage behind the dam, the unit for the volume or unit for the capacity is million meter cube. It may be in meter cube also. You can express in meter cube also, but it is million meter cube. You can also measure it in hectare meter also, but generally used terms is it is million meter cube. So whatever storage is created from the bottom of the river to top of the dam, there are some storages. So this storage is measured in million meter cube. You have to understand the term that capacity is measured in million meter cube in case of reservoirs. Now, what is the role of reservoir? Why this water is stored in a dam? Because you know that in India or anywhere in the world, the rainfall is not uniform at all places. All over India, rainfall is not uniform, and it is not uniform with respect to time also. Now what happens? Whenever it is required for the irrigation purpose, the water is not available in the river. It is dried up. Whenever it is required for the industrial purpose, water is not available. Or there is huge water available, but at the time of floods, it is available, which is devastating the lands, which is devastating the villages. But what happens? All the waters goes down, and for where suppose it is Cherrapunji, lot of water is downpoured on the Cherrapunji, but not available at the time of when it is required because it is already flowed down. So if we require it for the irrigation purpose, or if we require it for the water supply purpose, or we require it for the power generation purpose, flood moderation purpose, or fisheries, inland navigation or recreation, if we require it some other time when rainfall is not there, it is required to store the water behind a dam. We have to create a capacity of a reservoir which can fulfill our demand of irrigation, which can fulfill our demand of water supply, drinking water supply, which can fulfill our demand for power generation. And these are the major areas where there are a number of other reasons for which the reservoir is created. But these are the major areas for which we create a capacity of reservoir. Now, it is very much required to understand that capacity is generated. But if we see the section of a dam or section of a reservoir, you can see a dam is built here across a river. This is river. This is a flowing river. You can see from the arrow, you can see this is a flowing river. Now this is the top of dam. I have created this dam here. I obstructed the river. So I have created this much storage. So this may suppose X million meter cube volume is there. Now there are three zones. There are a number of zones also, but there are three major zones. First zone is called dead storage zone, and second zone is called the live storage zone, and third zone is, for our purpose, is the flood storage zone. You can say the to accommodate the flood. Now the levels related to it are known as: first, dead storage top level is known as the maximum drawdown level. Live storage top level is known as the full reservoir level, and flood storage zone is known as the maximum reservoir level or maximum water level. Now, why these levels are kept, or why these storages are kept? Actually, what happens whenever river water flows? It flows with some sediment, with some debris, with some material which encroaches the capacity of reservoir. Okay, and that material is normally deposited in the riverbed. Once it is deposited in the riverbed, that water we cannot use, or it is not advisable to use that water because it's a muddy water, or it is mixed with silt, or it's mixed with sediment. So that water is not advisable to use. So we keep some storage to deposit the sediment at that place, or we don't use that water. We keep, you can say, a buffer. So that portion which where we keep the sediment, or where sediment normally deposits, or where that part we are not using. That's why that part of water is dead. That part of what is dead. That's why it is called the dead storage. Okay, but from dead storage or minimum drawdown level, because from minimum drawdown level, because up to that level, after that level, we never deplete a reservoir. We never extract water from that. Therefore, we call it minimum drawdown level. Okay, full reservoir level is that level which is between minimum drawdown level and between full capacity of the reservoir level. Now, this is the level which is very much important level, because it's called the live storage capacity of the reservoir, or you can say it's a useful storage capacity of the reservoir. This is the storage from where we allocate water for irrigation, we allocate water for power generation, we allocate water for drinking water supply, and number of other benefits. We allocate water from this storage only. Now, if this storage is encroached by sediment, then whatever allocations we have planned, we cannot allocate in future, because what happens over the years, when dam is created, whenever flow is coming, this flow is obstructed by this dam. That's why this water is a still water. And that's why still water, when the flowing water comes into contact with still water, sediment drops down, because sediment carrying capacity of the river reduces, because every river has some carrying capacity. So whatever carrying capacity of the river is there, because of the velocity, reduction in velocity, whenever a flowing water come in contact with the stored water or still water, its capacity, it loses its sediment carrying capacity. So it drops the sediment. So whenever it drops sediment, it is deposited here. So whenever it is depositing somewhere here, then our live storage is encroached, we can say. Now, if live storage is, suppose I have taken X million meter cube of water. Out of that, if it is encroached by 20%, so X minus 20% water is now available after 5 years or after 10 years or after 11 years. So whenever I plan to allocate water for power supply, I have to reduce the demand by 20%. If somebody is asking for irrigation, I require this much millimeter cube of water. But you can say, no, my capacity is encroached. I cannot give that much of water because there is no water balance in the reservoir. So that time you can surely tell, okay, I have assessed the capacity of reservoir, therefore I cannot allocate this water. Otherwise, what will happen? Technocrats or academicians or students or technocrats, we people, we decide what is the capacity of reservoir remaining, what is the, but the people don't understand, beneficiaries don't understand. What they will tell, at it is written in the document that at this capacity, at this level, this much water is available, at this level this much water is available, and your reservoir is full. If your reservoir is full, how you are telling that there is no water available for irrigation? So you will be in the soup. So what you have to do, then you have to assess previous to allocation, you have to assess your capacity, whether it is encroached or not. I'm not telling that every year you have to assess. You have to assess in every 5 years at least, every 3 years at least. If you are in a gorge portion, if you are in a steep portion, it is better to assess every year. But if you are a different zone where a sediment transportation is less, or sediment rate is less, there you can assess in 10 years also. But in hilly areas or in landslides areas, there you have to assess every 5 years, at least in every 3 years, you have to assess the capacity of the reservoir. Otherwise, what will happen? Sometimes reservoir is live storage encroached by 50%, and you will not come to know. Because from the top of the reservoir, you will see that a lot of water is there inside the reservoir, but actually it is encroached by sediment. So it is for the civil engineers, especially the academicians and researchers, it is very much important to assess the capacity of reservoir, each and every reservoir, or it is very much essential for the government officials also to get surveyed this capacity of reservoir every 3 years at least, or every 5 years at least. So these are the levels. This because of the students, I have shown that everybody knows that this is a minimum drawdown level. This is full reservoir level. This is maximum water level. Maximum water level. Why we are keeping? This is known as the full pond level. That full reservoir level is there. Reservoir is full, but what happens? We have to keep some buffer space also. Whenever flood is there, for flood moderation purpose, we have to keep that storage in the reservoir, and afterwards it is released for other purposes. Otherwise, what will happen? It will create havoc to the downstream side. There's a lot of water is coming, and we are releasing through gates during the monsoon day, but we can save people whenever a rush of water is there, whenever flash floods are there. That time we can store some water in this flood storage zone, and we can save our lives, we can save our materials, we can save mankind. So for that purpose it is kept, but we'll restrict our capacity to this part only, that live storage portion and that storage portion up to full reservoir level. So before going ahead, I'll tell you this much capacity of reservoir we are taking into account. Suppose it is a X million meter cube. So we have to assess this capacity in the present scenario. Suppose the particular dam is built in 1950. Now it is the number of years have passed. 1950 means now it is 70 years. So after 70 years, dam might have filled with this capacity, it might have encroached with the sediment by around 50%, we can say, because if it is in hilly region, it may be more also. So it is necessary to survey all the reservoirs available in Madhya Pradesh or available elsewhere to assess the capacity. So my request to students is that this is a very good topic, and because you know that more than 3,000 number of big dams are there in India, and every state is having small dams, thousand number of dams, and you at your place you must be finding Tigra Dam is there, Harsi Dam is there, and Matatila Dam is there. A number of dams are there in your places also. The students can go, and whatever method I am suggesting you, you can select one of the method in that, and you can prepare some project for a reservoir, because Tigra is a very small reservoir, maybe around I don't know 4 to 5 millimeter cube capacity might be there. But if you can compare Bhakra, it may be around more than that, 50, 10 times of 20 times it may be there, or maybe 100 times also. So small reservoirs and big reservoirs. So for students, you can take a small reservoir for your project work. You can, if you can assess its capacity, it will be beneficial to government also. You can submit your project to your college, as well as you can submit that the college can submit in turn to government that our student has calculated this capacity of reservoir, which was previously x, and now it is x minus 5% or x minus 50%. So that report, if you submit, it's a very useful report for you. So mechanically you are not doing anything, you are doing a real job, real time job, and you will feel satisfied. Okay, this project I have done for the government of India purpose or government of Madhya Pradesh. So clearly understand, I am just in this webinar, I am explaining what are the methods available. In next webinar, definitely we will go for a particular method. So that we can understand, okay, this method I'll take for my PhD topic, or with this method I can take for the MTech thesis, or for the project purpose. Project purpose, number of your guides are there, or your teachers are there, they can suggest, and you can from your side also you can select some topics from this webinar. Now coming to sediment, I have explained you what is river, I have explained you what is reservoir, I have explained you what is the capacity of reservoir. Okay, our topic is assessment of reduction in capacity of reservoir due to sediment. So we have to understand sediment also. Capacity we have already understood. Now, what is sediment? Sediment is a naturally occurring material that is broken down by a process of weathering and erosion, and is subsequently transported by action of wind, water, or other means also. So these are the particles of earth. These are particles from the mountains. These may be particles from the riverbed. This may be particles from the river banks also. This may be particles from the farm fields also. So it may be pebbles also, it may be conker also, it may be rubbles also, it may be sand, it may be aggregate, any type of sediment which is encroaching our reservoir is called the sediment. Any type of this type of material which is encroaching our reservoir area or reservoir capacity is known as sediment. Now, sources of sediment, from where it comes, the source it comes from the whenever rainfall is there, then whole catchment there are droplets of water are there, and there is loose soil, so that time sheet erosion will be there. In throughout the catchment, the erosion will be there. All you can say the tiny soil particles will flow with water, so that is known as the sheet erosion. So that erosion will first deposit into river, and river will take that eroded material to up to reservoir side, and because of the dam construction, because of the dam obstruction, that portion of soil, or we call it silt, is deposited in the reservoir. So that is called sheet erosion. Gully erosion, sometimes small rivulets are there, small channels are there. So from that channel, because flow of water is very high at the time of monsoon, so with a great high velocity, it erodes the banks, it erodes the bed material also. So that gully erosion may be there, and loose soil is there, then it will erode everything. Stream channel erosion, we said banks and bed. Then there will be mass movements also, that landslides must be there, then avalanches must be there, earthquakes must be there, construction activities must be there, mining activities must be there. You can see number of photograph I've gathered here. You can see the rock type is sedimentary type. So it may crumble anytime and go to the flow with the water. There is heavy rainfall, heavy downpour. That time also a lot of sediment will be captured by flowing water and will deposit to river. There may be earthquakes, small earthquake may be there because this debris is created through earthquake only. So this earthquake material will finally go to the river side or downstream side. So this will also add to our sediment and it will encroach the capacity. You can see here landslide is there. Landslide material will also go. Then this is farm field. Whenever we irrigate our field, before that we plow the field. If we are plowing the field, means we are loosening the soil. If we are loosening the soil, and again if there is a rainfall, all loose soil will go to the reservoir. Okay, then there will be in Rajasthan, like you can say, in there are sandstorms, or like the wind is blowing very high. So that time wind erosion will be there. So all sand will get deposited in the lower areas, and it will finally deposit to the reservoir. It will encroach the capacity of reservoir. Now, uh, there are other things, construction fields also. There are maybe soil is loose, and then that time by time to time it is degrading its shape. So that is also possible. There are a number of other reasons also because of which sediment is generated. So sources of sedimentation. Now, what is the effect of sedimentation reservoir? Why we are bothering ourselves to calculate the capacity of reduced capacity of reservoir? That reduced life storage capacity adversely affect the power generation, irrigation, and water supply. I told you previously also, because that capacity we cannot give for the, it's not now useful because 20% is reduced. So we cannot use that capacity. And increased backwater levels in head reaches of the reservoir create problem of flooding in the back reaches, because that level we have not calculated because of slopes. You can see that increase, there will be backwater will be increased. Another thing is increased flood of the reservoir in upstream reaches create waterloggings also sometimes. There are formation of islands, there are formation of deltas. They choke irrigation and navigation and power outlets. An increase in weed growth resulting in more evaporation, because there is a lot of grass which is because of the swamps or because of the marshy lands, a lot of grass is developed and more evaporation is there. So in reservoir itself, because of this sedimentation, because of silt, the rich uh, soil mass is available. That's why more grasses, more vegetation is developed in the reservoir, and it create a capacity of it reduces the capacity of reservoir also, and it add to the evaporation. It add to the evaporation. So that is also this benefit or misbenefit of that. Um, Now, process related to movement of sediment movement. I have already explained that erosion in catchment and sediment transport are the two processes. First is the sheet erosion or something from catchment. It will come according to drainage density, according to vegetation cover, according to rainfall duration and its intensities, and how is the land use pattern, whether it is a farm field or it is a pakka field by concrete construction, or it's a pavement or it's a parking area. On that it is very much depend how much sediment will come. If it is a pakka area, no sediment will come, but if it is a loose soil, lot of sediment will come. So erosion in catchment from different types of fields or different types of areas or different types of watersheds. If it is a rocky watershed, then no sediment generation will be less from the catchment area. So there will be less sediment will be eroded from the catchment. And if it is a you can say it's a farm field. I told you, if it is jungle and it is their roots are uprooted, then that uprooted soil will also go with this sheet erosion. Now sediment transport, because of the flood, heavy flood, velocities are very high, and because of that velocity, banks and bed are heavily eroded, and channel geometry, channel slope are changed. Channel roughness is changed. So that affects the flow of water in river or rivulets or channels, and that is why more and more sediment is transported from, first it is collected from all catchment and deposited in the river, and then it is transported, it is flowed down, and it is flowed down and deposited in the behind the dam or behind creating a reservoir where we have created the reservoir. Now, what are the factors affecting this sediment in reservoir? So lateral and longitudinal valley slopes, they are a major factor. If longitudinal slope is high, then more sediment will come in within a short time, and if it is flattened, then less sediment will come. And length and shape of the reservoir, this is also very governing factor on that. Flow patterns of the reservoir, capacity of inflow volume ratio to trap efficiency, this is very important factor. Grain size distribution of the sediment means what type of sediment is there, if it is a loose material, if it is a heavy material, that also depend about it, how it is transported. What are the sediment discharges, how it is carrying capacity of river is that is also depending. Then mode of reservoir operation, how we operate the reservoir, on that also it depend how sediment is it is operated, sediment water is operated. And nature of incoming floods is the most important thing in this. Now, the major thing which I wanted to explain you, that whenever we are going to assess the capacity of reservoir, sedimentation, as you understood from the previous slide, the sedimentation is the process of deposition of sediment into the reservoir. Simple definition, sedimentation is the process of deposition of sediment into a reservoir. I have already told that I have created a dam here. This was the river here. So because of this dam, I have created this capacity of reservoir, this volume of reservoir I have created. But what happens whenever flowing water is coming to this side, and whenever silt laden water, QS is a silt laden water, this is a pure water, and according to QS is the silt laden water. Whenever it is coming in contact to this still water, it is losing its sediment here. You can see from live storage. This is live storage. Everybody can understand this FRL. This is MDDL. In between this is the live storage or useful storage. This is our dead storage. But this sediment first deposit here. It is not going to dead storage because we have kept this storage for sediment. But sediment is not coming here. After 2 years, this sediment will be deposited here. After 3 years, sediment will go this side. After 3 years, it will go here. Or after 4 years, it will go there. But after 10 years, it will go to, suppose, in dead storage, depending on the shape of the reservoir, it depends on the valley of the river. So the concept that our whole sediment will go and deposit below MDDL is correct, but it's not correct with respect to time, because it takes time to displace a wedge from live storage to MDDL. Because if this wedge, if it is deposited, if it is solidified, then it will permanently encroach the capacity of reservoir. You can see this is around 30% capacity of the reservoir is encroached by this in the live storage. So this is very alarming, and this capacity we have to assess. You can see if my volume is up to here, this is my full reservoir. We can see this much. If my volume is up to here, my capacity is up to here. So I have to calculate this capacity and inform to the government that this much capacity is already reduced. Now your available water is this much only, and utilize this water only. So for that, we have to assess this capacity, means you have to estimate how much sediment is deposited in my reservoir. That is the estimation. That is called the assessment. You have to assess how much you cannot go to the reservoir because reservoir is not small. You can assess this sediment if it is deposited in a bucket, if it is deposited in a tank, small tank. You can assess. You can dip a rod and see that how much sediment is deposited, or you can measure that. You can dredge that volume of sediment which is deposited from the small channel and see how much sediment was deposited. It's very easy to dredge that also, but in reservoirs, because it's a huge reservoirs, 100 square mile, 500 square mile, like that, their span is there, or their capacity may be 900 million meter cube, 1000 million meter cube. in that it is very difficult to identify how much sediment is deposited, because on the top of it we can see only water, nothing else. Okay, so you can understand that this is the culprit which is encroaching our reservoir capacity, and we have to assess as engineer, as civil engineer, we have to assess this capacity. Okay, now what are the method of estimation of sediment in reservoir, or you can say what are the method of estimation of a reduced capacity in reservoir? There are synonymous words. Sedimentation in reservoirs is directly proportional to reduced capacity of reservoir, because it is due to sedimentation it is deposited, and sediment deposition the capacity is reduced. Now assessment through charts and map, because number of reservoirs are there in Himalayan regions, number of reservoirs there in Deccan regions, in northern area, in southern area, in northeast area. So from 1947 or previous to that also, number of researchers are going on in Central Water Power Research Station and Central Water Commission, and colleges, good colleges are there. Our college, that MITS was very old college, IIT Roorkee was very old college. So they were doing research in this aspect, and they have some data of different reservoirs in these areas. So because we know the geography of our nation, that there are some fields, there are some slopes, there are some you can say Pathar, the Malwa is the Pathar region, you can say. So for this type of areas, and geology also, we know that geology is after 100 years we have fixed the geology also. Yeah, so based on these studies we have created some maps or charts, so you can assess the capacity by seeing the chart, which in which area my river falls, or in which area my reservoir falls. In that area you can tell that this much capacity of the reservoir is reduced. This is a rough estimate. Another thing is stream flow analysis, means sediment which is incoming into the reservoir and outgoing from the reservoir, we have to measure. Third is the empirical method. There is a IS code for this area reduction method. So you can use these methods because Government of India has, or Central Water Commission, or BIS, Bureau of Indian Standard, they have divided this lake shapes, and based on the lake shapes and lake slopes, they have devised some method. From that also you can calculate how much capacity is deposited, is encroached by sediment over the years. There are some mathematical models also, because nowadays all students are using mathematical models. You can develop 2D models also. You can develop an RGS also 2D models. You can run that model with the sediment for the sediment flow. You can run that model for the normal flow, and you can calculate with the available data. You can calculate the how much sediment deposit between the reach under study. And next is reservoir capacity through hydrographic survey. The spelling is, I think, mistaken. Hydrographic survey means it is through boat. You have to go and carry out the survey, and I'll tell you how to do that in short. And last, which is very much important for students, is use of satellite imageries or SRS technique. This is among all these methods, this is the SRS technique is the simplest method, I can say, which can be carried out without going on the field. Once you have to go to the field for collection of data, and after that everything you have to do in your lab, your computer lab, or your at home. You can sit at your laptop with your, but one good software is required. On that I'll tell how to do in short, because already we have passed, I think 40 minutes we have passed, so we quickly see these methods, and in next webinar I'll tell you how to do this SRS technique, and from that how we can assess the reduction in capacity of reservoir. Now first method what I was telling is the assessment through maps and charts. You can see this is a map of India. So iso erosion lines are there, iso erosion rate lines are there, and this is measured in tons per kilometer square per year. Okay, so this much tons of sediment is deposited in my, suppose this is Madhya Pradesh area. So normally this line where your city is falling, you can check that portion. Suppose it's Gwalior is somewhere here, so you can check, okay, in my area the erosion lines or erosion rate is 500 tons per kilometer square per year. Means if my catchment area of my dam is this much kilometer square, then I can say that this much ton will come to my dam. So you can assess, okay, you can convert, then always this gravimetric can be converted into volumetric. Tons can be converted into million meter cube, or tons can be converted into meter cube. You convert that tons into meter cube, then you will come to know, okay, this much sediment can be deposited in a year in my reservoir. So because every reservoir, every dam has a different catchment area. Tigra must be having small catchment area, Matatila must be having big catchment area, Krishna Sagar may be having very big catchment area. So depending upon the catchment area, that sediment rates are decided. So suppose if it is 500 tons per kilometer square per year, according to that I can decide my capacity. It's a rough estimation of my reservoir's capacity over the years. It is per year. Suppose we are assessing after 5 years, so we have to multiply by 5. If we are assessing after 10 years, so multiply by 10. So that much capacity of the reservoir is reduced, we can say. Okay. Now there are some charts, tables also prepared by Central Water and Commission based on they have done some survey of 5 numbers of reservoirs in Brahmaputra Basin. Gangetic Plains, they have done 9 number of reservoirs. East flowing rivers, 1 number of reservoir Godavari. Deccan Peninsula Zone, 62 numbers of reservoirs. They have, like that, West flowing river Narmada and Tapi, 45, like that. And they have decided that this much 1000 cubic meter per square kilometer per year sediment will come. 1000 cubic meter or hectare meter is a volume. So this much volume, they are given directly in the volume. So this much volume of sediment will be deposited in the reservoir per year in these areas. So this is also good guidelines. If your city is nearby to Narmada Basin or Tapi basins, you can take this 0.75 thousand cubic meter per square per kilometer as a rough assessment for your reservoir, and you can calculate arithmetically how much sediment is deposited in my reservoir. Now, next is estimation of sedimentation volume through inflow outflow method. It's a simple, looks simple, that you have to measure the inflow water from the inflow coming from the river to the reservoir, and inflow outflow from the reservoir, and how much sediment laden water is there. You have to measure the sediment in that, and you have to calculate what sediment is passed down to the reservoir, and you have to calculate the difference in that. So it is very, it looks very simple, but it's very tedious because we have to take measurements in that, and measurements are continuous measurement. Every hour or every 2 hours your measurements have to be taken, and you have to model it. So it's a tedious job, and over means whole monsoon period you have to calculate that. So 4 months, and it is difficult to sit there, and it's physically we have to measure. So it's very difficult to measure. Inflow outflow method, though we are using it in non-monsoon period, but in monsoon we cannot take because more sediment is coming in monsoon period only, and that time that method doesn't support us. Now I think timing is it is more 15 minutes I'll take. So there is another method is known as area reduction method. We can call it Borland-Miller method also. So this is also a good method in which at the time of calculating the capacity of reservoir on the basis of 60 reservoirs all over India, we have categorized the reservoir as lake-shaped reservoir, floodplain shaped reservoir, or hill type reservoir, or gorge shaped reservoir based on the slope of the reservoir and the capacity of the reservoir. So if we classify this in the reservoir, so this you can see this is a gorge shape of reservoir because water deposited in a valley only. This is a fan shaped reservoir. I have shown you the fan shape, or you can say lake shaped reservoir. This is a floodplain type. This is in between the fan shape and the this lake shaped reservoir, the floodplain reservoir. So like that, type 1, type 2, type 3, type 4, we have divided 4 types of reservoir. This is the reservoir type, this is the gorge type of reservoir, and type 1 lake type of reservoir. Now what happens whenever you decide that my reservoir based on the depth and the capacity and slope ratio, based on the capacity and slope ratio, if we decide that my reservoir is a lake type of reservoir, Then we can select this slope and capacity ratio, and we can select this. Okay, this is my lake type of reservoir. M value we have to calculate. If we have calculated that my M value is between 3.5 to 4.5, then this line we have to select and select that it is a type 1, means I am coming to the lake type of reservoir. And if it is a lake type of reservoir, if you see the code, you can see this graph. It is a percentage reservoir depth is given here, percentage sediment deposited is given here. So what is the lake shape of reservoir? It's a type 1 reservoir. You might have seen that it's a type 1 reservoir. So we have to select graph for the type 1 reservoir. So you can see type 1 reservoir. This is the type 1 reservoir. So at 60% depth of the reservoir, I can see the percent deposited of sediment is only 25%. So like that, you can calculate at each depth how much sediment is deposited. At 80% depth of the reservoir, this much capacity is my reduced. So that is a estimation, and this also gives very good result. It's a area. It is called area reduction capacity, and you can assess the capacity from these graphs also. If you decide what type of reservoir is this, because it depends upon the topography, it depends upon the geography of that area. So you have to decide that. And this is also good method for the project work. You can utilize this also. And then there is a, I forgot to tell you that whenever capacity is generated, we develop an area capacity curve. So that area capacity curve is nothing but at each elevation, what is the water spread area, and at each elevation below that water spread area, how much is the capacity. And that graph is always kept with the government, which is the custodian of that dam or custodian of that reservoir. So they are keeping this original area capacity curve. Now, whenever we calculate from any method the capacity at each level, we have to compare with the previous capacity. Then only we'll come to know that previous capacity minus this capacity, that is the encroachment in capacity that is deposited in the sediment deposited in the reservoir. So area capacity curve plays a very much important role in this, because that is the base of our study. If area capacity curve is not there, first we have to generate the area capacity curve for the time for which we are studying, and then after 5 years again we have to assess the capacity. Then only we will come to. For Indra Sagar, we did like that only. There was a area capacity curve available, but there was some discrepancy in that, because Indra Sagar dam is having number of channels, number of you can say channels are coming up to the reservoir. Not only Narmada, but there are number of channels coming to the tributaries of the Narmada at the dam point. That's why the shape of the reservoir is very tedious. And that's why that area capacity curve was not finalized. And that work was carried out by us, Central Water and Power Research Station. At the time I was working there. So we have created the original area capacity curve. And by that time now they are doing survey, and now every 5 years they are doing that area capacity, so that they can be compared. So these graphs are showing that it's a comparison. It's a previous area capacity, and this is new area capacity, and that reduction of that, the difference of that is known as the encroachment in the capacity of reservoir, or volume of sediment deposited in the reservoir. So this is area capacity is also good method, as I have shown. Now the hydrographic survey, I'm not going into detail of the hydrographic survey. It's suppose reservoir is created. If you have to take a boat mounted with some equipments and DGPS, so that you can see here that you have to create a baseline over the reservoir, on the reservoir, and on that baseline you have to measure depths in the of the water, depth of water, and also the depth of water, depth of soft bed and depth of hard bed, both you have to measure. And what happens whenever you measure this, you will get a sheet of water, sheet volume of volume of sediment you will get. And that sheet, if you calculate by the Simpson rule, if you calculate the volume of that sheet, you will come to know how much capacity is enclosed in the reservoir. Because it's a tedious method, and it is only done by the specialized persons who are having the specialized equipment, because it may be a multi-beam type of equipments, or it may be a single beam type of equipment. it depends upon the DGPS, the quality of DGPS you are using, quality of that eco sounder type equipments you are using, quality of beam you are using for penetrating the soft bed and hard bed. Then only, and it's a specialized manpower is required for that. And this is the proven method, because you will get exact capacity which is reduced, or exact capacity of sediment which is deposited. And it's a proven method, and every Indian government offices are using this method only. Irrigation department, water resource department, all are using this method. Through both they are surveying, but there are some shortcomings in this method also, because that I don't want to discuss all the shortcomings here. We'll discuss later on. But this is tedious method, but it takes around 2 years to 3 years to survey a reservoir, to a big reservoir, like you can say Bhakra Dam, or you can say Krishnaraj Sagar Dam. You may require some Khadakwasla Dam, or you may say Banshed Dam in Pune. So it requires some time. So 2 to 3 years are required to survey this. But there is one method which you can assess that is known as the SRS technique, or satellite remote sensing technique. By application of that remote sensing technique, your estimation of sediment deposition or estimation of reduction in capacity of reservoir will be very much easier than other methods. Whatever methods I have told earlier, they are all are either rough estimates, or it may be around, you can say it's a very tedious to do. Inflow outflow method is not possible to do by the student, or it is not possible also by the workers, also by the employees also. And also this hydrographic survey is also tedious, but it and takes time. But this SRS technique can be done within a year's time, within a 3 months time, and it requires only satellite images. The expenditure is only satellite images which we have to purchase. So listen carefully, that satellite remote sensing technique, you need not to go to site also. You have to go to site only for the collection of data. Once you have collected data from the site, now you can come to your desktop, or you can come to your laptop, you can sit in your office. You have to register your only this satellite imageries. You have to correct your satellite imageries, and you have to do work on the software only, nothing else. So it's a very good method, and for students this method is very much suggested, because me personally I have done 12 MTech thesis I have completed by this SRA technique method for different reservoirs in Andhra Pradesh, in Maharashtra, in Madhya Pradesh, in Karnataka also. And for even for this BE students also, we did some good project on this SRS technique. Now, as you know that I told you that bare estimation of sediment inflow into the inflow volume is not sufficient. How and where this sediment is deposited is more important. Means if it is deposited in live storage, I am more concerned to that. I am not very much concerned if it is deposited in the dead storage. So that is only volume. How much volume is deposited, that is not important. Where it is deposited is more important. So SRS technique can very correctly give that what is the location of that sediment, how it is, how it gives, I'll tell you. Now basis of SRS technique is, you can see I have created a dam here, and after creating this dam, this is in plan, you can see this is dam, and this is my reservoir water spread, you can say. Now this is my MDDL, so you can see this is my MDDL, this is my MDDL water spread, this is my FRL water spread. Okay, now over the years what happens, this sediment is deposited in reservoir. You can see that's hashed line are there. So this sediment is deposited in this valley also, and in reservoir also. Here this deposit, my capacity is encroached, my capacity is reduced. You can see for this reduction in capacity, this is my water spread, not this my water spread. Now for this reduction in capacity, this is my water spread. So this was the original water spread area. This is the new water spread area, or reduced water spread area. Like that, at another level, MDDL, you can see this is original MDDL water spread area. This is reduced MDDL water spread area. Now, how it is useful? I'll tell you. Because satellite can see from the top only. From the satellite only, it can see the earth, and it captures the pictures of dam or reservoir from the top. So it do not take depths it takes only plan. It can see the spread, but it cannot see the depth. Okay. So what happens whenever it moves? There is a path of a satellite which moves from our site. So after 22 days, or after 5 days, or after 3 days, that satellite will pass again to your reservoir, and it will take capture your picture. So what will happen that time? What is the level of reservoir? You can confirm from the government authority that okay, 5 September 2019, what is the level? So they can tell, okay sir, this is the level. So you can note that level, and you can note, uh, you can bring the image of that date, and you can calculate from the image what is there. Because September is the FRL level, you can say, because it's a full reservoir level. September, October, it's a full reservoir. No depletion in storage, because in September, a lot of rains are there. So no irrigation, no other things are there. So full reservoir level is there. So September image, you can see that this type of image you'll see on the image. I'll show you just like that. You purchase number of images, and you can go up to May image. So in May image, you will say your water spread area in the image will look like this. Now you calculate this area, you calculate in between also some images you purchase, and you calculate only the water spread area, nothing else. You have to calculate only the water spread area from the image. How? I'll tell you. I'll not go in detail. This is how much data you have to store on, like that. We'll go to another webinar and we'll calculate. This is the image. I think it's not that clear. But suppose this is, I think, Sriram Sagar Reservoir in Andhra Pradesh. You can see this is my dam site. Okay. And this is my water spread area. See, this is up to FRL level. This is my water spread area. Now, if I am able to calculate this much area from this image, and if I am able to take the imagery's date, what is the imagery date? It is 18 December 2002. Maybe it is uh, 3 or 4 meters down the FRL level, because it's not September image, it's a December image. So that time level you can take from the government office. Suppose it is 270 meter, suppose. So you can take out this image from here. You can calculate the area of this by some method or by software. Then at each and every level like this, you can calculate the water spread area. Now I'm not going in detail. These are details of reservoir. I'll just finish up this animal. Now you can see these are the results. What I did, I have taken September image. I have taken October image. I have taken November image. I have taken December image, January image. Like that, I have taken near about 8 to 10 images. I have taken for this Sriram Sagar reservoir. You can see the shapes of reservoir in satellite first, satellite image. Now it's a full reservoir level. You can see 294.96 meter. Then it depleted to 287.18 meter. Then to 261.84 meter. Then to 246.68. Like that, it is depleting, and now the reservoir elevation is like that, is depleting. The water spread area is also depleting. So this from 332, and this is 318. So this much we have, this much depth is now reduced. So therefore the areas which is delineated, it is not known as the delineation of the water spread area. Now this delineated water spread area I kept here for your so that you can understand. So this delineated area is this like that. So my reservoir FRL finishes here FRL finishes. Below that, 1 meter below this much image, you can see that last image. You can see very little water spread area is there. Now, what to do? I know this is this much square kilometer, x square kilometer. This is x2 square kilometer. This is x3 square kilometer, x4 square kilometer, and we know the level also. This is what is the level? 332 meter, and this is 332.34 meter. We know the difference between between these two, so we can calculate the volume between the two by the prismatic formula or by trapezoidal formula. Okay, because A1 is there, A2 is there. Okay, A1 and A2 is there. So A1 plus A2 under root of A1 A2 and bracket H by 3. That is the formula we are using to calculate capacity between these two levels. Again calculate capacity between this level and this level. Then again likewise at each level you have to calculate the capacity. Now then you generate the cumulative capacity between this and this. You have already calculated. Now what is the capacity between this and this, or this and this and this, and like this? You have to generate the cumulative capacity. Now you can generate a curve. When you are having at each level the capacity, then you can generate a curve. You have a formula, you have used the cone formula, you have developed a capacity, you have developed a capacity curve also. Results are then compared to the original ground survey or hydrographic survey or original capacity curve. In between there must be some hydrographic survey also. So you can go to hydrographic survey result, or you can go to some in between original ground survey results are there. You can compare with that also, and original capacity survey also. So you can see I have compared these capacities. These are the elevations and these are my capacities. You can see this is at the MDDL and this is the FRL. So this FRL, the SRS technique I have done, and I have calculated the water spread area. I have generated the area capacity curve. I have generated area elevation capacity curve, and from that I have calculated what is my volume. And volume is shown here. This is the SRS volume, and this is the original volume of 1970 when dam was constructed, and this is the in between intermediate survey volume. This is so. The difference between this and this will give you the capacity encroached, capacity reduced between these two surveys, and capacity reduced from original you can compute from here. So from graph also and from that calculation also you will come to know how much capacity is reduced. So that is very important, that original capacity survey must be there, capacity curve must be there. There are some corrections are there, we'll understand in next webinar. Image corrections are there, tail end corrections are there, pixel identification corrections are there. That is will not go into deep. This is the image of another reservoir. I'll quickly finish this. This is Jaikwadi Reservoir of Maharashtra. It's a very big reservoir. We took around 2 months for this, doing this one. Huge reservoir. Its hydrographic survey was not possible, and that government requested to do that capacity survey of this, and we got very good images of that because clouds were clear. We took cloud free imageries, around 12 to 13 imagery we have purchased from NRSA Hyderabad, now NRSC Hyderabad, National Remote Sensing Center. From there we purchased hardly, it was 8,000 per image was there, and we have purchased around I think here 13 images we have purchased, and we have calculated the reservoir capacity or reduction capacity of reservoir. How I have calculated, I have told how to calculate that, and I have generated that graph also. And you will be surprised to know that this work was done by the students only. The Jaikwadi is a small village. From their college we have picked up the students. They were very much enthusiastic to do this survey, and they have selected this site and they done this job. Not only me, my team was there, my engineers were there, but there were 6 students and they were very good students, and they have gone to the site to check the actual scenario of the site. Sometimes what happens, you can see here, you can see the pixels are not very much clear. So we have to sometimes see whether it is an island or here you can see some island is seeing. So their ground truth sometimes are required. So that time our students, they were very much beneficial to us. They cooperated us and they gone to site and they searched all these points through cameras. They brought the photographs and all, and we have decided what is the capacity of reservoir. So there are a lot of problems in this also, SRS technique also, but we'll overcome that problem. There will be no means that is more not very much tedious. You can solve these problems and you can calculate the capacity easily, other than the other projects, other methods. So we have calculated this capacity. The reduced capacity is there. You can see this is the original map, black color. Hydrographic survey map is this is showing here, and then 2003 we have developed this. That hydrographic survey was challenged by us because that was showing some wrong results, and that were accepted by them also. And now it's okay. Now they are doing every 5 years there. I have done in 2003. Now they have done in 2012 also. Every 5 to 10 years they are doing this capacity survey. Why satellite remote sensing survey technique is good? Because it's cost effective. No need to take too much of labor for the hydrographic survey. No risk is there. We have to go to reservoir. Lot of jungle is there. We can stuck up. Sometimes we cannot get signals also. So it's cost effective. It saves times also. Hydrographic survey, you are giving 2 to 3 years to give us to do a survey, to complete a survey, and that too it's may not be very much accurate at some channels where you cannot go. You do not know whether it is part of channel or not. So you stuck up sometimes in hydrographic survey. So it's time saving. You say only in 2 to 3 months, or even I have done one reservoir, Shiravati reservoir. I have done in 21 days because they were requiring that capacity of reservoir. So I have done in 21 days. So there's if we only one person can do that. Less manpower is required. Requires very less manpower because only one modeler or one student or one or two students can do this work. They very clearly they are use the software and calculate the capacity. And since satellite images are available at an interval of about 3 weeks, now it is available maybe in 5 days also. Previously it was 3 weeks. In 5 days intervals, these are available. So good satellite images are available. So you can use that. Capacity can be established for earlier year also, because hydrographic survey you can calculate the capacity only in the present time. But satellite imageries, you can go to the historical satellite images also, and you can calculate the capacity in the previous year also, and you can establish a rate of sedimentation by this method also. Now accuracy is better in fan shaped reservoir, but for gourd shaped reservoir the accuracy is little less, because for each depth of reservoir there is a very small reduction in area. That's why. So in fan shaped reservoir, for small depth reduction, there is a huge reduction in the water spread area. So sometimes some benefits, some disbenefits are also there. Now we'll come to the end of this. Some limitations that I told you, that revised capacity below MDDL and above MWA cannot be determined. That you have to write me in the on the mail. Some of the student can show me why capacity below MDDL cannot be calculated by SRS technique. Why we cannot calculate, and why we cannot calculate above MWL technique. Images are available. Why we cannot calculate? So you can send me the mail. Only student. I don't want from the engineers and professors and all. Only student, that too B student, can tell me why we cannot calculate the capacity of reservoir below MDDL or above MWL. Okay. Last but not the least, that hydrographic survey below MDDL may be essential to estimate the changes below MDDL, because we cannot do by satellite imagery, so we have to do a hydrographic survey. So integrated method we have to use sometimes, and special care we have to take, because students are doing, they should be highly skilled, they should know the software, otherwise there will be huge mistake. Okay, so these are some of the important aspects of that. I'm not going on that detail. So it's a less tedious and requires less manpower. Even your professors can guide you at your place, and you can choose nearby reservoir, and you can go to the nearby, collect the data, so it will be beneficial for you. So thank you very much for attending this seminar. For